All right, so welcome back. Today is, we're going to get more into Java. Remember that we are online, so if you have any questions, you can post to either Piazza or you can go ahead and post directly to the live stream on YouTube. Before we get started, though, I wanted to make sure that we're following along with the Gantt chart. Again, this is completely optional. If you have another means of organizing yourself and organizing yourself for the rest of the semester as far as this course goes, great. But I'm going to update my Gantt chart here so that I reflect the work that I've done so far, right? I'm simulating the work that you should be doing. For example, I've already read all of the handouts and understand that there are these three programs. One of them I've probably seen before from last semester, either the midterm or the final or whatever it was. It was a win percentage expectation. One of them is the entropy, given a string or given a file full of letters and characters and stuff like that, I'm going to have to do some frequency analysis, and I'm going to have to plug it into the Shannon entropy function and output a result. Then finally, I'm going to have to process a file and produce this game report that says that this publisher released this many games, et cetera, according to that data. So file I/O, clearly, basics like input and output, string manipulation, et cetera, et cetera. I'm going to have to pay attention to all of that, and so that's what we're going to start covering over the next couple of weeks here. Nearly everybody got their Lab 1 done. If you did not get it done because you registered late, that's fine. I opened it back up. I will accept it till Friday if you registered late. But otherwise, if you didn't get it done because you blew it off, that's not a good way to start. But I think like 95% of everybody got it done. Keep it up. Keep up the good work. All right? And finally, what should I be doing today? Well, I should start by setting up and outlining my programs. Right? You're now set up on Eclipse. You should be making those files. You should be working ahead and designing your test cases here. But you can take a leisurely pace for a lot of this stuff because you've started to work ahead. So I'm just going to mark this down as, well, I've got Eclipse set up, so maybe that's 25% done. As I progress forward, I'll see myself, moving along this axis here and making updates. All right? I'll go ahead and save that and quit out of that. So to understand those three basic programs, to implement those three basic programs, we're going to have to understand the basics of Java, because that's what we're going to be doing them in. Just to review from what we looked at last time, Java is a class-based, object-oriented programming language. What that means as far as we're concerned is that everything in Java either is a class or belongs to a class. If you're coming from, say, a Python or a C background, where you can create a function, and that function can exist in and of itself, right? You don't do that in Java. Instead, that function or that method is what we call them in Java. That has to belong to some class. So for example, the square root function that lives in the math library in C, that lives in the math class in Java. And we'll look at how to use that here in a second. Otherwise, classes are simply units of code that are declared in their own source files. So if I create a class called Hello World, capital H, capital W, that's the convention, then it must be in a source file named capital H, capital W, helloworld.java. In the background, my IDE is doing all the work for me. This Eclipse IDE, Integrated Development Environment, is doing everything for me. It's already, it's compiling every second in the background after every keystroke or something. It's reporting back to me any problems, any warnings or anything like that. I don't have anything open right now because we're going to review what we did. But otherwise, it's compiled to a .class file, right? And it's run on a Java virtual machine in the background. Write once, compile once, run anywhere that has a Java virtual machine. Right? Classes are also organized into packages. They're simply directories or folders on your computer in the class path. unl.cse. There's a folder called UNL. Under that, there's a subfolder called CSE. You could have as many subfolders as you want, but that's ultimately the package. So if I create a class inside that package, up here, this package declaration will be unl.cse with a semicolon at the end. If I put a class file at the root of all this stuff, then that's called the default package. If I didn't have any package declaration here at all, that's known as the default package. That's all the way at the top of the root. Of course, it's complaining about that right now because this file actually exists in the UNL CSE package, but it doesn't have that package declaration. Restoring it makes it compilable. If your packages don't match your package declaration, it's not compilable. Generally, you want to put things into some sort of package to organize your files. Okay? Let's go ahead and repeat what we did last time, or repeat what you did in your lab yesterday. We'll go ahead and create a new class called Hello World. World. And I'll also click down here to automatically generate that main. I did that manually last time, but I'll go ahead and let it do it for me this time. Right? There's the package declaration, followed by a semicolon. There's public class, and then hello world. That's what I just created. There's a nice to-do here. Somebody asked, how do you get rid of those to-dos? Or what's the use of to-dos? Let me go ahead and expand this out. Here we go. So in the demonstration on the video, or even in your lab, down here there was a tab called Tasks that collects all of the to-dos that you've got within your project and brings them to your attention so that you can jump immediately to them. I don't see it anymore. Oh no. Have I permanently deleted my to-do or my task bar here, my task tab? Nope. How can I restore it? Window, show view, and I think it's task list, isn't it? Or maybe it's tasks. There we go. Tasks. Right? It was just hidden somewhere over here. Your IDE is completely configurable. What you can do is, I want my tasks down below. Okay, fine. Go ahead and drag and drop. Right? You can move those around just like you can move modern browser tabs around if you want. Right? And it looks like all of my stuff has a lot of to-dos here. I've got a lot of stuff to do, but don't worry about it. Right? Where's this one? Where is it? I'm in CS2. So it should be up here. Right? There it is. Right? If you click on that, it takes you right to the code that is referring to that to-do. Once you've done it, for example, system.out.println. Sorry, I can't type today. Hello world. I've done that. I'm going to go ahead and get rid of that to-do, and you see that it disappeared down here. Right? That's how you take off those tasks. If I'm not really good about, basic style items, like I put everything like this and it's completely unreadable, you can restore that how? How did you do that yesterday? Shift Command for Mac, it's going to be Shift Command F. For Windows, it'll probably be Command Alt or Shift Command or Shift. There is no command. Shift Control F. Right? Format. Okay. There we go. All right. Well, that's nice, but I'm not getting any of my documentation points here. What needs to be documented is the class itself and any non-trivial functions. Main is kind of considered a trivial function because everybody knows what that is. That's the main entry point of any program. So I'm only going to document my class here, and I'm going to do it through doc-style comments. If you just have a /* and then a */ that's just a regular old comment, a multi-line comment. Multi-line comment here. Right? You can also have single-line comments with / or // Is that a / or a backslash? // good. So // this is a single line comment. Right? All right, so that is the same basic syntax as C. But a better way of doing this, especially now that you have an IDE to do it for you, is to start out a comment for a class, documentation for a class, or documentation for a method using /**. Don't hit anything else, just hit enter. And it automatically generates this stuff here. There's my authorship, and of course I should probably put in the date. The date is, what is it? 20th, thank you. And purpose. A basic hello world program to get you started. Right? Every class needs, every non-trivial class, let's just say every class because there is no trivial class. If you made a trivial class, why did you make it? But anyway, if any class needs class documentation, which goes right above the class declaration, any non-trivial method needs documentation as well. This is a trivial method because everybody knows what a main is, but if you want to do it, you could do the same trick here. What's the purpose of this? It's a main function. You know what it is, right? That's superfluous documentation. You don't need that kind of documentation there. When we get into object design, then you'll see even more trivial methods that you don't need to document, getters and setters and stuff like that. Okay? All right, so packages provide, in fact, what I'm going to do is I'm going to go ahead and make sure that you have this. You should have a version of this already, but I'm going to go ahead and put this into the notes anyway. Or Java. There we go. There. All right. Questions so far? Otherwise, let's start highlighting some things. There is C-style syntax. Right. What do you see that's familiar for those of you with a C background? Comments are the same, right? Comments are the same. Single line is / comment. Multi-line is / star .. star /. Right? What else? Semicolons. Semicolons at the end of all executable lines. Lines, there we go. What else? Sorry again? Brackets to denote code blocks. Brackets denote code blocks. Right? They begin and end chunks of code. For example, functions, classes, etc., and eventually loops. Right? What else? Yeah. Args, right? Command line arguments are supported. And what is that thing right there? Square brackets. Square brackets denote what? For arrays. Good. We'll talk about arrays here today, and then then you'll never use them again. Right? Instead, you'll use something better. Hello world itself. What do I have there? Double quotes denote strings. Right? And in Java, strings are different in Java than they are, and they're much easier in Java than they are in C. They're really a breeze, right? What else? Anything? Good style? What do you see as good style? Well, Control, Command, Shift, F, and it does the work for you. But how did it do it? Right? What did it do? Indentation, right? Same consistent indentation, white space, right, etc. Right. We might come back with some more, with some other similarities to what we see in C. But what are some immediate differences? And it's may not also altogether be completely clear yet. But in contrast to say C, in Java there is no memory management. Right. It is handled for you. So if you remember, if you're coming from the C background, to create an array, you have to dynamically allocate a chunk of memory, right? Calling, what function do you call to do that? Malloc, memory allocation. Once you get done with that chunk of memory, to be good stewards of your memory, you have to do memory management. You have to clean up after yourself. How do you free up that memory? By calling the free function, right? There's no such thing in Java. Instead, there's automatic garbage collection. Java has automatic garbage collection. You don't need to worry about it at all. If there's an array that you're no longer using, Java is able to detect that you're no longer using that array and makes it eligible for garbage collection. And then when it feels it's best to do so, it goes and cleans it up after you. You don't have to worry about that stuff. In fact, there's really not a way that you can really force garbage collection. There is a supposed way that you can do it, system.gc, right? That's that's short for garbage collector. Call the garbage collector. That's just making a suggestion to the garbage collector. Maybe you need to clean up, right? And the garbage collector can still say, no, it would be more costly to clean up than to just leave that memory wasted. I'm not going to do it, right? It has very sophisticated algorithms that go that determine when is it ideal to clean up memory that no longer is in use versus, well, you don't need any more memory. I don't need to clean it up. It's not harming anything. It would actually be more wasteful time-wise to clean up that memory because it's only 1 byte over there. Who cares, right? It makes that decision for you. So even if you try to call it, there is no guarantee that it'll actually run. Okay? That's called garbage collection. It's also portable. You write once, compile once, run anywhere. Right? I don't want to give a history lesson on Java. It's over 26 years old by now. But it originally began as a language for cable top boxes. They wanted a language that would run on any manufacturer cable box, and so they wanted a language that would be, compile once and then port it over to a software interface for that particular one that they wrote for that particular cable box, or whatever. It never actually made it onto any cable boxes, but it became a popular language in and of itself because it had a lot of these features. In fact, I don't have them here, but who was the guy that came up with Java? You found his birthday yesterday, right? Mr. Java. I forget what his name. Gosford or Gosling. There you go. Gosling. He came up with Java under 5 principles. One of them was that it looks familiar. That's why it has all the C-style syntax. One of them was that it's easy to use. That's why it has no memory management. He wanted to take the good parts of C, C++, and all that family of languages, and then he wanted to also get rid of all the aspects that he thought were bad about it and bring in a couple of other things, etc., to make a new language. So it's an improvement over C? Yes, no. That's why we have so many languages, right? Everybody thinks that one thing is an improvement, while there are plenty of other people that think that that one thing is an unimprovement or a disadvantage, right? Whether or not a language is good or bad, or some aspect of a language is good or bad, that's completely in the realm of opinions. And that's why we have so many languages. I hate that thing about that language. I'm going to go ahead and make my own language. Excellent. Now we've got another language. Right? I hate that thing about that new language, but I like the thing that they were fixed over there. I'm going to create my new language, right? And that's why we have new languages. Whether or not they catch on, right? Who knows, right? I forget what the quote is, but they're. I'll misquote Churchill. Whenever somebody asks me which is the best language to learn or which is the best language to use, you always quote Churchill, who was asked, about democracy. Is democracy a good form of government? And he says it's actually the worst form of government, except for all the others. So take any language, Java, PHP, Python, whatever. It's the worst language, except for all the others. Right? They're all bad languages. The only good language is natural language. When we get to the Star Trek era, where we can tell a computer exactly what we want and it understands exactly what we want, then that's the great language, right? Because then you don't have to think about it. All right, portable. It's also, one thing I didn't mention is it's the backward compatible for the most part, right? For the most part. In other words, if you take Java 1.0 code that was written 26 years ago and you port it and you recompile it, even if you don't recompile it, you still should be able to run it on a Java virtual machine today, version 1.0, 322, whatever we're up to now, right? And Java has actually, the developers of Java have bent over backwards to ensure this at the expense of some warts in the language that remain there to this day. Generic types and erasures are something that we'll talk about later, right? So they wanted it to be stable, right? There's no, not a lot of people are going to adopt a language if it's changing every 18 months so that you can't use old stuff anymore. If your stuff breaks every 6 months, every 12 months, that's not a language that you're going to use, right? All right, so let's talk about the basics. And the basics start with variables, right? Just like C, but unlike, say, Python, if you're coming from a Python background, or MATLAB, or PHP, or JavaScript, those are all dynamically typed languages. Java is a statically typed language. Java is statically typed, meaning that all variables and their types must be declared before you use them, right? And types cannot change. Once you've created a variable that is designated as an integer variable, it will only ever be an integer variable. You can't suddenly make it into a string variable. So let's go ahead and go over here to, I'm going to open up demo here instead. And this is just going to be my workplace here. Anytime that I write a chunk of code, I'll go ahead and cut and paste it and put it in the notes so that you don't have to, so that you have it in the notes. But otherwise, I need an executable environment here if I'm going to execute anything, and I can't do that in the notes that I'm writing over there. So let's go ahead and create a variable that can hold an integer. Int x is equal to 42. Right? Same rules as, say, C. It is a 32-bit signed integer, so the maximum value that you can support is 2.147 billion or thereabouts. You can go into negatives as well as 0. So 0, 1, positive 1, or negative 1, et cetera, et cetera. Here I've set it equal to 42. You can always reset it, otherwise it wouldn't be a variable if you couldn't vary it, right? Later on you could say x is equal to 101, right? And that's perfectly fine. That changes its value there. What you cannot do is something like this. Why? Now, in C, this would be okay, right? What would happen? Truncation, right? In other words, it would be okay in that the compiler would say, yeah, I'll go ahead and do that for you. 3.14, well, I can't handle 0.14, chop, throw away. That's called truncation. In Java, that's not allowed. Java, in some other classes I teach, I usually point out that Java and some other languages are a language that will say, you ask it, I want to shoot myself in the foot, and it's saying here, do you really want to do that? Right? And but a language like C is just going to say, what caliber do you want? Right? So what's happening here is I'm losing precision through truncation, and it's not going to let me do that. If you really want to do something like that, that's perfectly fine. You can do, well, what would you do in C? Double and typecast it. Well, I can't do it here because I can't force it to be a double, but I can force it to become an int, right? And now it's perfectly happy with this because you are making the conscious decision. Yes, I wanted to force that 3.14 to become an integer using truncation to become 3 to put into x, right? All right, you can also have double values. You got to spell it right though. Pi is equal to 3.14. That's perfectly fine without having to reassign it. I can go ahead and assign an integer value to it because 3 is actually 3.0, right? There's no problem there whatsoever. It does support single characters, although they're of extremely limited use. Initial is equal to C, right? There we go. But more importantly, it supports full strings. Name is equal to Chris, right? String full name is equal to name plus my last name. Oops, there we go. What did I just do there? I added them together. What is Chris plus Burke? Me, right? That doesn't make any sense. Plus in this context, it does not mean addition. Plus in this context means string concatenation. Now, if you're coming from a C background, what would you have to do? You have to, you'd have to use strcat. You'd have to make sure that the memory was allocated. You'd have to make sure that it was null terminated. You'd have to do all this stuff manually. No problem here whatsoever. The string class is built into the standard library. Java.lang is the standard library. And you can concatenate, no memory management issues, no null terminating character issues, nothing like that. Most languages are actually like this, not like C, where they've got some sort of built-in primitive type or built-in class to handle strings for you. Some other languages use different symbols for concatenation. Java uses the plus operator here for concatenation. But you can't do something like this. Full name is now equal to 42. Right? There is no way that you can do something like this, even if you say, no, I really, really want to do that. No, I don't know how to take 42, the number, and convert it to a string. You got to do something else. Okay? So, if I do have a string that has a numerical value, how do I convert it to an integer so that I can add it to some other integer value? Integer dot parse int number. So if you're coming from a C background, I heard A to I or A to F, what you can do is you can convert that to a number and capture the value. Right? Why? There we go. What if you wanted to parse a double string other number 3.14? Right? Int, or not int in this case, but double xyz. There we go. Double dot parse double other number. Excellent. Right? That will take those numbers and convert them for me. And then I can print them out if you really want to. Printf, y, and z. And you'll see that those values, then I converted them from a string into a number, and then in order to print them out, I'm converting them back to a string, but that's all done automatically. 42 and 3.14. Right? Okay. So I'll go ahead and cut and paste this and make sure that you have it in the notes. There we go. All right. Before, I guess you should also point out that you also have Boolean values. Boolean is student, say, equals false. Later on, I can go is student is equal to true. Right? This is in contrast to C. In C, do you have Boolean types? Not without bringing in a library, std_bool. And even then, it's just a bunch of macros. It's not actually a type, I believe. Instead, 0 is false, and 1 or anything other than 0 is true. In, say, Python, how many people are coming from a Python background? Okay, then I'll stop drawing parallels to Python if nobody's taken it. But if you're coming from some other background, you might have the capital T true and capital F false or something like that. Here we have these keywords false and true, and they're all lowercase. It's not the same thing as true. That Java doesn't know what that is. Right? Those are the keywords are all lowercase. Not only that, but you can't mix types. Just like you can't make a string into an integer without some conversion, you can't make a Boolean into a number or vice versa. I can't say is student is equal to 1 just like I would in C. You can't do that here. 1 is a number. It's not true. Right? True is true. False is false. 1 is 1, and 42 is 42. Right? So you can't do something like this. Nope. There we go. All right, and I'll make sure that I tack that onto the notes there. Question online here. There we go. Thank you for, that's the quote that I was looking for. There are only two kinds of languages. The ones that people complain about, and then the ones that nobody uses. Right? There we go. Command line arguments. So like most languages, you can do command. You did it in your lab yesterday, right? Yes? No? Okay. Just to reiterate, in Java, it's a little bit different. There's not an argc, there's not an argv. Instead, they're in one thing. They're in this args array. The first one is actually the first argument. It's not in C, arg sub 0, argv sub 0. That's the name of the executable file. You don't have that in Java because you know what the executable file name is. It's demo or hello world. You're the one that named it. Why do you need to know what it is? Right? So that first argument, system.out.println args sub 0. This is the first argument. We'll start at actually 0. Second argument would start at 1, 2, 3, etc. How do I know how many arguments there are? System.out.println number of arguments is going to be args.length. Right. Dot length is a property on all arrays. Just as I said that in contrast to C, Java does not have memory management, it also doesn't have bookkeeping. Remember, bookkeeping, that anytime you have an array in C, you also need to keep track of how big that array is so that if you pass it off to this function, you can say, here's my array of integers, please add them up. By the way, there are 10 of them, right? C has to be told that, and you have to do all your own bookkeeping. But here, once you've created an array, dot length will continue to, is fixed, and that will tell you how big the array is. It doesn't grow, it doesn't shrink. That's why we don't like using them. But in this case, we are. Now, if I'm going to go ahead and run this, then what do you think is going to happen here? Do you see a way of giving a command line argument? Nope. So, index out of bounds exception. There was no arguments here at all. Therefore, there's no first argument. That array has a size of 0. In fact, if I put this up here, that'll at least execute and tell us that there are no arguments. And then, the first time that we try to access one that doesn't exist, we get this red text. This red text is exceptions, right? And in C, there are no exceptions. The way that you do error handling in C is through error codes, that you return an error code, or if you don't do any error handling, what happens? Seg fault, bus error, stack smasher, if we ever saw that one, right? That one was cool. A couple of other errors, and it'll just die, right? In this case, however, anytime an error happens in Java, an exception is thrown. It's a completely different way of handling, of doing error handling. We'll talk about this in detail later on. But otherwise, in your IDE, it manifests itself as this red text telling you that some error happened. Nicely, it tells you what line it happened on, and even nicer, it's clickable. You can jump to that line by simply clicking on it. Right? And there's a little bit of an error message there that you can decipher. How do we provide command line arguments? Because we're not at the command line technically in an IDE. We create what's called a run configuration. So you run something once, then you come up here to the play button, but hit that down arrow to expand this out, run configurations, and arguments. So let's go ahead and provide those arguments now, A, B, and C. Right. Apply that, run it, and you see that the number of arguments is 3, and it's got A, B, and C. Okay. So the first argument is at args of 0 in contrast to C. Also, you don't have to worry about the size. Arg C is taken care of in the dot length property. It's actually it is a property. Okay. So those are the basic variables. You also have conditionals, and loops, right? And arrays. Question mark, right? Let's talk about conditionals first of all. What kind of conditionals do you want to support? What do you know from C? If, else, if else, switch. We'll keep that in our back pocket for now. If, else, if, right? All of those are all supported. That's a loop. We'll get to loops in there in a second. All supported, right? All conditions must be actual conditions, Boolean expressions, or statements, or variables. Right? You can't do what we, because there are Boolean variables, we can afford Boolean variables now, right? True, false. There's no more. Well, if it's equal to 1, if it's 1, right, that's true. If it's negative 2.5, that's also true. Or 0 is false, right? You don't do that anymore with Java. Instead, you have to make sure that it's an actual expression. So what I mean by that is let's go ahead and try to do what we would do in, say, in C. Int is student is equal to true, right? If they are a student, then I will give them a discount. System.out.println discount. There we go. It's not going to compile because that's an integer. That is not a Boolean expression. How should I do this instead? This should be a full-fledged Boolean because we can afford it now. Right? Back in C, we couldn't afford it. And it should be true or it should be false. Right? And that, well, there's no discount here because they're not a student, so it doesn't print anything. If it's true, then it will print that they get a discount. Is this good practice? If is student is true, if it's equal to true. Why write? You'll find me quoting often this semester. What is it that he says? Why say many words when few words do? Right? Yeah, why write many pieces of code when one code will do, right? No, keep it short, right? Don't do that. That's bad practice. You can add if they are a student and if they are a grad student. Boolean or they're a senior, right? Is senior. Citizen, not senior as in school. True, right? So if they are a student or they are old is senior, right? Then they get a discount. There we go. Discount. Otherwise, if they some other expression, I don't know, if there is student and I don't know, rich is rich, then we're going to charge them full price or something like that. In any case, the takeaway here is that the Sheffer stroke, those are called Sheffer strokes, or they're called vertical strokes, or sometimes they're called pipes, whatever you want to call them. That is the expression for or. This is the expression for and. Right? And or can be combined in any, of course, you could also say and x is greater, has nothing to do with discount anymore, x is greater than 42. And of course need x here, equals 20, there we go. So is this gonna print out discount or not? No? Are they a student? Yeah. Are they a senior? Yeah. And is x more than 42? I don't know. Okay, they get a discount. Why? What's that thing called again? Where, oh, the first expression is true, and then this is an and. I don't care what this is. It's called short-circuiting, right? If it doesn't have to look at the rest of the expression, it's not going to. This is a left-to-right expression, okay? Otherwise, if I put this first, say x is greater than 42 and the rest of this stuff. Now is it going to print discount? Let's have an else here just to make sure that it actually prints something. Nope. Why still a discount here? False and is student is true, so that's false, and then or true, and that's why it makes it true. So what do we need to do if we want that I want this thing and then this thing all together, since it's left to right? Parentheses. What do we call that? That's not even a coding thing. That is a math thing, right? What do you do first? Parentheses, then exponents, multiplication, division, addition, and then subtraction. What is that called? Pemdas, exactly. Pemdas is the same thing here. And is this going to print discount now? As long as I save it. Nope, it won't. So PEMDAS rules in any programming language. I think that there are like one or two that you might be able to find that PEMDAS does not rule and that it's something else entirely. Why? Because it's familiar. That's how mathematics was built several hundred years ago, and that's why languages are designed to be familiar, even with hundreds of years of old math. Yeah? Yep. So let's go back here, and they're not a senior, right? Or it is not the case that x is strictly greater than 42. Should I write that, though? What's the opposite of that? Is less than or equal to, remember. Right? So that's a much better way of writing it. But yes, you can use the exclamation point as the negation operator. So and is the and operator. Right? The Sheffer stroke, or pipe is the or operator. The exclamation point is the negation, And there are a couple of others, but we won't get into those. There are bitwise operators, single ampersand, single shepherd stroke, caret, right? But unless you're going to get into bit twiddling stuff, you don't need to know those. Right? And you probably should stay away from them unless you absolutely know what you're doing. Okay? All right. Loops. What kind of loops do we know? Oh, before we go on, somebody did mention switches. Switches, you do have that support in Java. You can switch on integers. You can switch on strings. Careful of fall through. You need a break statement on everything. If you don't know what I'm talking about, don't worry about it, because that's why I don't generally cover switch statements, because they are very, very brittle. Easily broken. All right. Loops. For loops. For loops. And while loops. And there are do while loops. But I'm going to go ahead and hold that in our back pocket too until we get to something that we can do a for each loop on, which we'll do by the end of the day here. Yep. But there are do while loops, are all supported. Right. So a traditional for loop over here. Let's go ahead and get rid of all this. Let's just go ahead and print out hello 10 times. So for int I equals 0, I is less than 10, I plus plus. Right. System.out.println, hello. And also print out here I. Concatenation, I can concatenate strings together. I can take integers and variables and concatenate those together, and it all works. Right? No fuss, no muss. Much better than C. Right? And this will print out hello 0 through hello 9. Why did it not print out the last terminal value here? Because when I hit 10, is 10 strictly less than 10? Nope. And that's when it broke out of this loop. What's an equivalent while loop? While I is less than 10, then print this out. There we go. Except, uh-oh, it doesn't know what I is anymore. I declared it right here, didn't I? Well, I did declare it right there. But what's the scope of I? It's only for the for loop. It is limited in scope to that loop only. If you want to, you can, of course, create I outside. Right? And now it exists for both of those loops. Bad practice. Limit the scope of all variables. Limit the scope unless you have to do something else. If you want it like this, fine. Go ahead and create that variable later. Now, this I right here is not the same as this I right here. This I has been declared for this loop. Later on, at line 10, that I no longer exists. If I tried to print it out, for example, right, it's going to complain that it doesn't know what, it's complaining down here for other reasons. We'll get to it in a second. But I cannot be resolved to a variable because the life cycle of that I is from line 7 through line 9 because of how I scoped it and declared it. There is no I on line 10. Right? So, nope. Now there is an I on line 12, but it's a brand new I. So what value is stored in that variable right now? Nothing? Junk? Dead beef, right? Those would all be excellent C answers. We don't know. It could be 0. It could be garbage. It could be dead beef. What do we know about it in Java here, though? Java says, wait, that's uninitialized. I have no idea what's in that value. I'm not even going to compile for you. Again, it's saving you from shooting yourself in the foot. The local variable I may not have been initialized. I'm not going to even compile. If you're going to create a variable and then use it, you need to initialize it first. And now it's happy with it. It is scoped to before and after this while loop, though, now. So what's this going to print? And I'll go ahead and get rid of this chunk here for a second so that we don't confuse it. Oh, cool trick. How did I do that? Highlight a section of code, and then, well, max is going to be command / and you can toggle it all you want. Right? Most IDEs support something like this. The CS50 IDE did, didn't it? I think, yeah. And on a Windows machine, it's going to be control / I believe. Right? But I'll go ahead and get rid of that for a second. What is this going to print? hello 0, hello 1, dot, dot, dot. What's the last thing it's going to print? 10. Ah. Yeah. So what happened? What have I got here? An infinite loop. How did you kill this in C? Control C. If you started it with a play button, how do you stop it? With the stop button, right? And then you can clear this out. My error here was what? I never incremented it. I++. Right? For any, do we all understand what plus plus is, by the way? Since nobody's saying that they came from a Python background. Can you do that in Python? Nope, I don't think so. You can do this in most languages. Plus plus simply just increments the value by 1. It takes, if 5 was in there before, plus plus now is 6. Right? Plus plus again, now it's 7. You can also do minus minus. What do you think that does? Decrements. Right? Okay. So I'm adding 1 each time. What is this going to print now? Hello 0 through hello 9, and then 10. Why? Where is that coming from? Right there. Right? Why is it 10? It printed 9, then it incremented to 10, right? And then it comes back up to this while loop, and is 10 strictly less than 10? Nope. Breaks out of the while loop, and then it prints hello again here. Right? Let's see that in action, but I don't want to do it too much here. So we'll go up to 5 instead, 0 through 5. I want to see that in action. So what I'm going to do is I'm going to show you how to run a debugger. Well, this little bug icon up here, it'll execute this program just like any other, but it executed it all at once. If you want to pause the execution of a program, how did we do it in GDB? You set a breakpoint. And so I'm going to set a breakpoint right here. Double click this blue thing right here, and now you see this blue dot. If you want to get rid of a breakpoint, double click it again. I'm going to re-enable this, and I'm going to hit the debugger, and it's going to ask me, well, it might ask you if the first time, but it'll ask you, do you want to go into debug perspective, which is, there's a little debug perspective up here. It allows you to see everything. It allows you to see the code that you're executing here. The console is still down here, but now I've got this new thing over here. I can look at all of my variables, right? I can expand them out and see how they change, right? Instead of setting manual watch points or anything like that in, say, GDB, I can step through this program and see all the changes. I can resume, I can stop the entire program, or I can go line by line. Let's go to the next line. You'll see a change. Let me go ahead and unexpand this. Contract it, I guess, is what we'd call that. And do you see an I over here, by the way? Not yet, because before line 12, it doesn't exist. Let me go ahead and step over line 12, and you'll see that it magically exists now, and it has a value of 0. Right? Yes, you can go about changing stuff if you want to. I wonder what would happen if I said it like this. What's going to happen? Nope, it's already, I mashed the keyboard. If it was negative, then it would go up. But in this case, I've already exceeded 5, so it jumped out. Right? All right, stop. I didn't mean to do that. I mashed the keyboard accidentally. Go ahead and hit it again. And now, step. I can highlight it, and then step, print. You see it down below in the console. Fine. It is still 0. Step, and you see that it was incremented at 1 after I executed line 15. Step, 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 step. I don't want to do this anymore. Right? Set another breakpoint and resume to that breakpoint. Step. Right? Another cool thing I'll show you later on is you can do conditional breakpoints. Well, here. I can show you one. Let's see. Let's get rid of that one. Where is that breakpoint? Breakpoints. I want this one. Is this it? Yeah. I'll go ahead and make this a conditional. Suspend when true if I is equal to 3. Let's go with 100. Right? Stop this first. save it, or is it automatically saved? Yep, it's automatically saved. So, for example, suppose I needed to do some sort of debugging when this was going 10,000 iterations. Do you want to sit there and go 1, 2, 3, 4? Something happened at iteration 5,000. Okay, next. Once you get to 5,000, you press next too many times, and now you're at 5,001. Nope. So let's go ahead and execute this again. Oops, compiler error. I cannot re-resolve to a variable. Yeah. Enable. It's on line 12, right? Oh, it's on line 12. That's the problem. It doesn't exist. Okay. Kill that. I'll go ahead and set it down here to line 14, and then make it conditional based on I, when I is equal to 100. There we go. And run it. There we go. It stopped. It stopped there. I'll go ahead and resume. There we go. And it stopped again. And if I look at my variables, refresh. Oh, come on. That's just a bug. That's a glitch or something. The variables should still be up here, but you can see. Oh, no, wait, what am I doing? All right, I never stopped it to begin with. It was still running the old one. There we go. Now let's try this again. There we go. No. Where's my breakpoint? Demo I is 1. Oh, no, it stopped, isn't it? Huh. But there was no stop button, so it didn't, like actually died. Oh, I never saved. Duh. Did you see that? No, let me do it again because I just did it automatically. There's an asterisk up here that tells you you didn't save. So save, 10,000, save. There we go. There. Now it is paused at 100. It has been stopped when I is 100. And if I continue, step, then I can see what's going on. You can create conditional breakpoints. You can condition them on, where is it? There it is. A Java exception. So, I don't know, null pointer exception. There we go. We'll get into exceptions later on, but what I'll do here is integer x. I is equal to x. Let's say that. Terminate. Yeah. There we go. It's not even going to let me do this. I'll have to come up with a better way of doing this later on to show you. But anyway. There is, and let me go back to my perspective here. Once you're in this perspective, you can always change your perspective. This is my Java perspective that I was in before. Many of you had already seen maybe the Git perspective from yesterday or from video 0.2 where we walk you through how to use Git in Eclipse. Always change your perspective back to what you're doing at that point. Yeah?
For the exceptions, you can always set it to a command line argument that doesn't exist.
You could, but if you want to stop on a specific type of exception, like null pointer exception or index out of bounds exception or file does not exist exception, whatever that might be, if you want to stop for a specific reason, right, then you would need to specify that which reason you want, basically. Right? For loops, while loops, do while loops, great. I won't even bother going into a do while loop, but they all have the exact same properties as, say, you're familiar with from C. Right? Same keywords, same everything. Questions so far? No? If you are coming from a Python background, again, I don't know how many people are, but if you are coming from a Python background, you generally don't have this. I mean, you do have this kind of stuff. It's just that you don't have this kind of syntax. If you were in Python, what would it look like? If you wanted to go for 0 up to 10, for I in range 10, right? Then you do something, right? That's a basic for loop. Otherwise, you do have while loops. While is student study, or something like that. Obviously, this will not compile because this is not Python. But you have while loops, just slightly different syntax, exact same behavior though. For loops, while loops, the continuation condition is checked at the beginning. While loops, you have to make progress towards that termination condition within the loop, etc. Right? Okay. What about arrays? Well, there's no garbage collection, but Java does support traditional arrays. Right? There is no memory management. So to allocate memory, you use the new keyword, and you do not need to worry about cleaning up or garbage collection. Instead, forget about it. There is no free, right? There's not even an option to do this. So let's go ahead and go back over here to Eclipse, and let's go ahead and let's create an array that can hold 10 integers. Well, it's going to be an integer array. Let's call it numbers. Right? The square brackets denote that this is not a regular old integer. Instead, this is an integer array. Right? And if you want to allocate, right now, how big is this, by the way? 0? It doesn't even exist. If I tried to do anything with this, it would be null, right? It would be like creating a pointer that points to dead beef or points to nothing or points to null. You can't do anything with this until you allocate memory for it. So, new integer array, how big do you want it? That's how big I want it, 10. You can also put that into a variable if you want to and use it instead. Now, this is at this point in the program on line 9, numbers is an array that holds exactly 10 integers. Here is a slight difference from both C and Java, or what we've seen in Java so far. In C, if I asked you what is in that array that I just allocated, what would you say? Dead beef, garbage, 0, no idea. It doesn't specify. In Java, however, a default is provided. The default is always 0 for numbers. It is always false for Booleans. It is always null for any other types. So let's go ahead and print these out. For int I equals 0. I is less than n, the number of elements in that array. I plus plus. System.out.println numbers sub I. That's my index. Why did I start it out at 0? All arrays started at 0. Unless, I think that there are at least 2 or 3 people here coming maybe from a MATLAB background. Is that true in MATLAB? In MATLAB, where do the indices begin? 1, exactly. Right? Why? Because MATLAB, right, is equal to plus. Again, you'll find, why does a language do it like this? Well, you go back to the language designer and you ask them, and they say, because. Right? Numbers of I. There we go. So if I print this out, then it'll print numbers sub 0 through numbers sub 9, and you'll see that they're all zeros. That is a default value in Java for arrays. Right? If you want to set them to something else, I want to set the first one to numbers sub 0 is equal to 42. Right? Numbers sub 9 is equal to 101. Right? 101. And you'll see that these are changed. 42 is first, 101 is last. What if I tried to set something that did not exist? Numbers sub -1, -1 is equal to 4. It's not going to ask you, are you sure you really want to do it in this case? It's also not going to ask you, are you really sure that you want to do it in this case? Instead, what's going to happen, what we already observed with respect to the command line arguments, a index out of bounds exception. Right? -1 is not a bounds for length 10. Neither is 10 for something that is of size 10. Because if you start at 0 and there are 10 of them, what's the last number? 9. And so index out of bounds exception for 10 as well. Right? I don't want to have to do my memory management, my own bookkeeping, remember, because this is Java. N, what's n? I forget about n. Right? How big is that array again? Numbers dot How did we do it with a command line arguments? Length. And you get the exact same behavior here. Right? Well, except for, let me get rid of this. There we go. There. 42 through 101. Right? All right. I don't want to have to do a traditional for loop either. Right? Again, this is a richer language. We can afford more things. Right? So instead of a traditional for loop, I'm going to have what's called a for each loop. Now, in some languages, they actually use the keyword for each. You can see that it's not highlighting and it's not compiling either here. So Java, does it have for each? Nope. Instead, it uses the same old for keyword here. But what it does is it has slightly different syntax. Instead of using an index variable, starting it at 0 and going all the way up to the length and increment by 1, what I'll do is I'll say for each integer x in the collection numbers. System dot out dot println x. Now I can't print out I, so I couldn't cut and paste what I did on 14 because there is no I anymore. There is no index variable. This is all automatic. It starts at the first one, and behind the scenes it creates an index variable for me and takes care of all those details. It checks, am I done yet? Nope. Am I done yet? Nope. Am I done yet? Right? And it also takes care of incrementing to the next x. The only thing that changes in this entire thing is the value of x itself. So let's go ahead and see this in action. 42 through 101. All right? Yep. Oh, how do you save? Control S. Yep, somebody answer that online. Right? That's universal. Control S or Command S is how you save in any application usually. Anyway, so much more convenient syntax. Again, the way that you read this is for each integer x in the collection numbers, do the following. Right? If it were strings, then you would say for each string x in numbers. Obviously, it's not compiling though. Why? Because those ain't strings. Right? Go back to int. Right? Great. I'm going to go ahead and cut and paste this and put it in the notes and then tell you to never use it again. Oops. Sometimes you will be forced to deal with traditional arrays, but if you ever have a choice, and once you see it, you'll never go back, right? So this is like driving my old 1993 Ford Festiva, my first car. I don't have anything much better. It's still a Honda Fit. So I certainly have a type. But if it's a choice between a 93 Ford Festiva and a choice between, say, a Cadillac or whatever you want to drive, Lambo? No? Okay, whatever. Then you're always going to choose that luxury car. Don't use arrays. Use a list. A list of integers. Integer. Got to spell it right. Numbers is equal to new array list. All right. Let me walk you through this as I highlight these because it's not compiling. What is a list? Well, a list is in a library that is not included in the standard java.lang package. So let me hover over this and let me import that thing. Right? And let me import this thing. I'm just selecting import here. And you'll see up here that the code has changed. If you have an external library that you want to use, in C, we did include this library. In Python, you use what? Import as well, I believe, right? Yeah, something like that. Otherwise, in Java, you do the same thing here. You import the Java utility called ArrayList. You import the Java utility called a list. And once you do that, it knows what it is. Let's take an aside here, and let's try to do some math. So int x is equal to 2. I want to compute the square root of x. So in C, I would do something like this, square root of x, right? And then I would capture it in a value. But I can't do that here in Java. Right? This is an aside. It has nothing to do with arrays or array lists or anything like that. But it does have to do with importing external libraries. Remember that Java is a class-based object-oriented programming language. everything belongs to a class or is a class. Does this square root function looks like it belongs to a class? Nope. In C, it's perfectly fine because it lives over there by itself outside of any classes in the math library. In many other programming languages, it's already also, there's a basic math library that's already brought in. But in Java, everything belongs to a class, is a class, or belongs to a class. And in this case, the square root function belongs to the math class. So if you want to use any math library stuff, you would use math.square root, math.sine, S-I-N, math.cosine, C-O-S, right? What else would you want to use? Math dot, hey, that's a cool thing that pops up in my IDE. A whole list of stuff that's available to me. I can convert something to radians. Neat. I can use the pow function, raise x to the power y. I can do the floor function. I can do the arc sign, right? All this stuff is available to me, including constants. E, 2.71. Anybody know other digits? No? Pi, which, oh, it's right there. 2.71828, blah, 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 blah. And then here, pi, 3.14159, blah, 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 blah. Right? So if you want, you can have your pi, you can have your e, you can have whatever you want. Right? But if you want your square root, then it has to be math.square root. Did I have to import it up here? No. Nope. Because as you'll see here, if I follow this, it is in the java.lang library, that package. That package is automatically brought in for you. You don't have to include anything at all. Otherwise, without that package, you're not getting anywhere. Right? Without that package, I don't even think you could do basic ints. Right? So it's brought in automatically, and you don't need to worry about these imports. But if you bring in something that is not in the java.lang package, something that is in java.util, then you definitely do need to import it. Right? Once we've imported it, we can use it. So if I were to create an array, I would have to specify how big that array is. That array holds 10 integers, 20 integers, 30 integers. That array can't grow, it can't shrink. This list can. If I want to add numbers to it, I can go numbers.add 10, 20, 30, whatever you want. On line 10, how big is that list? 0. On line 11, after I've added 10, how big is it? 1. It grew magically and dynamically and automatically. Now it's of size 2. Now it's of size 3. If you want to know how big it is, system.out.println numbers.size. It's not linked. It is actually a method that you have to call and to tell you how big it is. What's it going to print here, by the way? 3, because I put 3 things in. All right. You can put stuff in. Can you take stuff out? Yep. Remove that 30. And now how big is it? 2. Oops.
No, you have to put in the actual zone that you're removing. So I think
Technically, there's an issue going on here just because I chose to be integers. All right, let's change tracks here. Chris, Joe, and Jane. There we go. Now I can't string remove Chris. All right. Actually, let's remove Jane first, and then we'll remove me. So how big is it now? It's of size 2 because I removed that string. Right? Note here, what did I do to change that midstream here? All I did was change this thing inside this Langle Wrangle. This is called a parameterization. Before, it was a list for integers. Now it's a list for strings. What do you think would happen if I tried to add something that was not a string to this? Numbers.add 10. You can't do that. Why? You told me that this list was for strings. Is 1, 0 a string? Nope. So, no compile for you. Right. By the way, I changed it to names, and I'm still calling it numbers. Does that sound like good style to you? Nope. So change this, change this, change this, change this, cut, paste, cut, paste, cut, paste, cut, paste. Or right click, refactor, rename to names. Done. Right? And now I still can't add this, but so be it. There we go. I'll go ahead and leave it there though. System.out.println names. If I just print it out, it'll look like it's an array because there's Chris, there's Joe. I removed the last one. So what would it look like before I removed anything? I added Chris, then Joe, then Jane, all in order. So that's the order that you have because it's a list. I removed Jane from the end. What if I removed myself first? Right? If this were a regular old array and I had 3 things and I removed the first one, I would have a gap, right? But there's no gap here because everything automatically shifts for me. Joe and Jane. Yeah?
Is there a way to like remove from a specific spot in the array?
Yep. So let's go ahead and say names.remove. This is actually why it was compiling and running, but giving me an exception. You can remove via unindex. So remove the thing at index 1, and then let's print it. So what's that going to remove? Is that going to remove Joe or Jane?
Joe.
Jane. Why? This is at 0 index. This is at 1 index. And so it'll end up removing Jane. What if I had instead removed the thing at index 10? Do you see anything at index 10 over here? Nope, 0 and 1 only. So that's why it was giving me the exception before. Index out of bounds exception. Index 10 is out of bounds for a list of size 2 or length 2. Can you still what? Yeah, that's difficult because there are 2 remove methods, and you would have to say, I want that remove method, and so you'd have to do some explicit typecast. I don't even think so. That's one of those warts that's there for the last 25 years because of backwards compatibility, type erasure. So unfortunately, I don't think so. I'd have to look into that further though. Right? Once you have that, of course you can add, who else? John. I think I've already got Jane in there, but let's go ahead and try it again. There we go. So, oh, I didn't print it out. Joe, there we go. Let's add John, Jane, Joe, and Joe, and Joe. Actually, it'd be funnier if it Daryl and Daryl. Nobody knows that old show. Bob Newhart. There are these 3 yokels that would come in, and he said, I forget his name, but he said, and this is my brother Daryl, and this is my other brother Daryl. Right? So, 2 brothers named Daryl. So, are we able to have 2 Daryls in there? Yes. Right? So, duplicates are allowed. It is 0 indexed. There are no gaps. It grows as needed. It shrinks as needed. Right? All automatically. Right? Now, seeing this as your Cadillac, are you going to go back to plain old arrays? Nope. Use this. Right? Yeah. That's a good question. I think it's going to end up removing the first instance. So names.remove the first Daryl, and it only removes 1. But if you remove all, there's not remove all. All right. Remove any. I think that there is like a names dot remove. Oh, that's all. But it takes another collection. Right. So it takes another list of names, and then it'll take out all of those names that are in that other list. So list A, set minus list B. Right. Another question? No? Right. Any other questions? Otherwise, we're good to go, and we'll continue on Tuesday. Yeah. Just a second.